right. Well, good afternoon. I'm very happy to have been invited to participate in this important conference and that we get to spend this time together. By way of introduction, my name's Jason Ross, and I work in the United States directly with Lyndon LaRouche on his science research team, also known as the basement. Can you hear me now? Great. Okay. So the basement has been working with Lyndon LaRouche for nearly a decade now, and our role has changed over the years. We were initially constituted to work on economic animations, and then the basement was tasked with animating the most essential part of economics, the creative process itself, the discoveries that drive economy forward. So we focused on a narrow path of discoveries, from Kepler, Gauss, Riemann. After this work on the practice of science itself, LaRouche has assigned projects on science and economic policy, from space exploration to large-scale infrastructure, from planetary defense to fusion, and from metaphor to well-tempered musical tuning. His most recent assignment to us has been to develop the concept of mankind as the measure of the universe, by a fuller understanding of creativity as a force of nature, of creativity as a natural principle, like gravitation, electricity, or any of the others. And to do this from the standpoint of the Russian-Ukrainian scientist Vladimir Vernadsky. So the topic I'll be focusing on today is a Promethean approach to developing new forms of fire, Lunar Helium-3 for a fusion-powered mankind. I'll use the specific and the necessary prospect of developing fusion power and exploiting the most useful fuel for this, which is helium-3, and that this expresses the most true identity of the human individual, a creative Promethean identity. Among life, it is only human beings that change their relationship to nature over time, and we do it willfully. We do this by discovery. So although this is the natural condition of man, this discovery is not what always happens. Today we see the BRICS nations developing in a very positive direction, as we've seen through this conference, while the British Empire, the imperial outlook, is seeking to derail this and prevent development. This is oligarchism. So the ancient story of Prometheus is the most compact statement of the fight between humanism, development, and oligarchy. So Aeschylus tells the history of Prometheus in his play Prometheus Bound. After Zeus, the chief of the gods of Olympus, denied mankind the use of fire, Prometheus brought fire down from heaven, from the oligarchy, and he gave it to mankind. For this, Prometheus was punished by Zeus with the torment of being bound to a rock to have an eagle, Zeus, eat out his organs every day. But Prometheus knew that he was the victor, and he didn't regret what he had done. He couldn't have taken away from him the fact that he had done the right thing. So this use of fire, Prometheus giving mankind fire, this was the first technology. This was the first existence of the human species. With the use of fire, we are no longer a biological species. We are uniquely the cognitive species. So let's take a look at what Prometheus thought of mankind before the gift of fire. Prometheus says, this is from Aeschylus' play, he says, first of all, though they, human beings, first of all, though they had eyes to see, they saw to no avail. They had ears, but they did not understand. But just as shapes and dreams, throughout their length of days, without purpose, they wrought all things in confusion. They had neither knowledge of houses built of bricks and turned to face the sun, nor yet of work in wood, but dwelt beneath the ground like swarming ants in sunless caves. They had no sign either of winter, or of flowery spring, or of fruitful summer on which they could depend, but managed everything without judgment, until I taught them to discern the risings of the stars and their settings, which are difficult to distinguish. This means the calendar. Yes, and numbers too, chiefest of sciences, I invented for them. And the combining of letters, creative mother of the muses' arts, with which to hold all things in memory. I, too, first brought brute beasts beneath the yoke to be subject to the collar and the pack saddle, so that they might bear in men's stead their heaviest burdens. And to the chariot I harnessed horses and made them obedient to the rein. So if we think about all of these changes, the calendar to know when we should plant crops, creating dwellings, houses for our health, animals to help with our labor, wheeled vehicles pulled by beasts, music, numbers, and understanding, thought. Think of the condition that Prometheus said, though they had eyes to see, they saw to no avail. How many people today does that describe? So from this gift of fire, Prometheus says mankind will learn many other arts from fire. And indeed, fire is the basis of technology. With basic wood fire, we could cook food, we could heat our homes, we could provide light and safety at night, and we could change materials. Some rocks could be made harder, easier to chip to sharp tools. We could bend wood by boiling it first. Right? Then a new kind of fire opened up a whole new domain of potential. This new fire was charcoal. Charcoal is created by burning wood without air. You burn the wood in a pile covered by earth, as you see here. So charcoal, which has the water and the impurities removed from the wood, burns hotter and is very pure. With charcoal, we made the first machine, the first new machine, the chemical machine, metallurgy. The Bronze Age began. So let's take a look at an example of this. So here you see two stones. The one on the left is green, and the one on the right is gray. There are physical differences. The colors are different. The densities are different. Maybe one is sharper than the other. Maybe one is heavier. But the importance between these two stones, maybe one you can use for drawing. You can crush the green stone and paint with it. But the true importance of that stone only comes with the use of charcoal. So we'll see this example using a torch instead of charcoal. So the rock on the right was the gray rock. It's glowing, it got hot. Nothing happened to it. It's still a rock. On the left, you can see what's happening to the green rock. Right? It actually transforms, it melts in the end, and it forms copper. So these two things look very different, right? A green rock and metallic copper. Without charcoal, without the chemical power of this fire, you could never make this change. You can't just beat the rock, you can't yell at it, you can't step on it. You need charcoal, and it's a new form of power. This is the beginning of making new materials. If you add tin to copper, you create bronze. So somebody studying what's in the earth later, if you find bronze, this is a material that never existed before human beings. It's a newly created substance, never existed before. Humanity became a geological force, changing the crust of the planet. So in order to make these metals, lots of woods were cut down. The forests were destroyed. They were burned to make charcoal. And one of the first environmental regulations was made centuries ago to protect forests from charcoal burners. But do you know what saved the trees? What saved the forests of Europe? Coal. Coal saved the trees. Because with the use of coal, which we can get to higher temperatures, and much more easily than burning trees to make them into charcoal, we saved the forests. Wood could much better be used for making a house or furniture instead of burning it. And with coal, we could also make the first powered engine, the steam engine, which we could make with coal. So remember, Prometheus said that he gave the gift of using animals to help us in our work. Now we have rocks to help us do our work. Coal can help us do our labor. So, plus, with the development of this, we could let horses take a break. They could rest. The train can carry things. Later, we had another form of fire, petroleum. With petroleum, we could have the internal combustion engine. And even though we don't have wings, human beings could fly. We did not make an airplane with coal. With petroleum, we did. Distances became shorter, time became smaller, humanity became more connected. The discovery of electromagnetism then let us transfer power over thin wires instead of carrying large amounts of coal. And electric motors dramatically transformed production and factories. So let's take a look at the present day and the use of electromagnetism. Here's a chart that shows the correlation between per capita electricity use, going to the right, compared to per capita GDP, PPP. Now, GDP is not the most accurate way of describing economic development, but this chart makes it very clear that if you don't have electricity, you're poor. So even though some disgusting people say that we should have appropriate technologies for Africa, say solar panels, windmills to pump water, instead, you need real development to have a developed society. So coming back to where we're going, breakthroughs in chemistry allowed new processes such as refrigeration or the creation of artificial fertilizers by Fritz Haber. This one discovery by Fritz Haber, that one breakthrough, increased the number of people that could live on this planet by billions. This one discovery. Think about how powerful that is. Petroleum has chemical uses. We transform it into other things. I don't know if you know, but plastic comes from petroleum. So just like today, we don't burn wood as much. We use it to make things. One day, we will, it should be very silly that we burn petroleum instead of saving it to make things out of. Much more useful. So what is the new form of fire? What will take us to the next level? The answer is it's the power of the nucleus. Now, far more powerful than ancient machines like the lever or the screw, far more powerful than chemical changes of combustion and engines, is the potential of the atomic nucleus, the most advanced form of fire that we know of. So even though nuclear science began over 100 years ago with the work of Henri Becquerel, the Marie Curie, this domain has not been adequately explored, and it has not been cultivated. It has not been developed fully. And the remaining mysteries and the potential provoke more fear than they do make us reflect on our power, as they should. So why hasn't nuclear power been developed, and what is it? So radiation. Radiation was discovered as a mysterious new form of power that just came out of certain materials. It radiated from them. So in addition to the radioactive uranium and thorium that were already known to them, the Curies also isolated polonium and radium, which are much more radioactive. But even radium, very radioactive radium, it is not powerful as an energy source. You would need, per family, you would need 100 kilograms of radium per household to provide the needed power for your kitchen and your lights and these things. 100 kilograms of radium per household. Not very efficient. That's a lot. That's not how we make power. Nuclear power plants are not based on radiation. Radiation's no good. We produce our fire, our nuclear fire, not from radiation, but from fission, which is when we force an atomic nucleus to divide instead of emitting small pieces spontaneously. So by deliberately organizing certain nuclear isotopes, human beings are able to create chain reactions of fissions that cause other fissions. allowing for the very rapid release of the power in the nucleus. In fact, the first atomic scientists were so shocked by the amount of energy that they believed that the law of conservation of energy simply did not apply. And it doesn't. So on the left, you see the spontaneous decay of uranium as it turns into lead. Each arrow along the path happens all by itself, automatically, spontaneously. A tiny amount of power is created. On the right, you have what occurs in our nuclear power plants, where a neutron coming in hits uranium, causes it to break into two large pieces, and releases those three other neutrons you see at the bottom. Each of those can then strike another uranium and cause it to fission. If you make the fissions occur very, very rapidly, you have a bomb. If you make it happen at a rate that you control, then you have a nuclear power plant. Different. So today, a few grams of uranium have as much power as tons of coal, or barrels and barrels and barrels of oil. And a nuclear economy can provide other benefits as well, more than electricity, right? We can irradiate food. We can do nuclear medical imaging, nuclear medical scans, nuclear medical treatments. We can treat cancers, and we can detect smoke. Smoke detectors use a small amount of a created radioactive isotope to determine when there is smoke in the air. So overall, why has the power of nuclear science not been developed? What happened? The answer is Zeus, and we see it in this chart here. So this is another chart. This is over the time of the United States. This is per capita power use in the United States. How much energy is each person using over time? And there are two things that we can observe in this. First, it goes up, mostly. Second, the type of energy changes over time, moving to higher forms of fire that we have discovered. That's the general trend, but take a look at from 1960 until today. What's different? The trend has changed. Power is not increasing. In fact, it's actually lower now. And the new form of fire, nuclear, didn't become a dominant source. This is unusual. If we look back, coal has almost completely replaced wood. This didn't happen with nuclear. Why are we still burning coal when we could be using nuclear? Well, the reasons are false environmentalism and real colonialism. By and large, the developing nations were denied the credit necessary to build nuclear power plants, despite the efforts of many to help them. Then you have the environmentalist movement, which is a ridiculous concoction created by such people as Nazi Prince Bernhard of the Netherlands and the disgusting oligarch Prince Philip, who wants to reduce the world population by billions. Environmentalism just declared that anything people do is unnatural, by definition. Right? If we do it, and nature does not do it by itself, it's somehow bad, unnatural. Isn't the power of the human mind a force of nature? Where does this come from, right? Why were nuclear plants targeted in particular? Why were they not built? And instead, we're using coal plants. Why did this happen? So this chart also shows where the John Kennedy administration expected us to be today. So John F. Kennedy's administration believed that we would be at point A, using nearly twice as much energy now, having twice the availability. Also, if you think about world use, world per capita energy use is less than a fourth or a fifth that of the United States. So if you imagine what kind of increase would have been expected now for the US, and you think about how much it would have to be increased worldwide to reach this level, it's a stunning amount. So it's going to be impossible to do this without implementing fission, including the thorium cycle studied in India. This is a necessity. Without this, we cannot assure the dignity of the people of the planet. But we need even more. We need a higher kind of fire. We need nuclear fusion. So, unlike fission, which is the splintering apart of a large nucleus, Fusion, on the right, is the combining of two small nuclei. It creates an order of magnitude more power than fission does, and it creates a different kind of power, especially with helium-3. So let's get into a little bit of the nuclear physics here. Don't be scared, it's drawn with a pencil. Okay. So here are 4 different kinds of nuclear fusion reactions. And if we take a look at them here, so let's go over what we've got. On the top row, you see deuterium and tritium. Deuterium and tritium are types of hydrogen. They're called isotopes of hydrogen. You see they each have a blue, in this diagram, a blue proton. And then deuterium, 2, has a total of 2 nucleons. So it has also a red neutron. Tritium, 3, has a total of 3 nucleons. The 1 proton, which makes it hydrogen, and 2 neutrons. So most of the laboratories today work with this. And you see what it creates. It creates a neutron, it creates helium-4, and it creates some energy. Here's the problem, though. Well, actually, one more thing about this. It's very interesting. Deuterium and deuterium, the second reaction, these can combine in fusion and create a large amount of power. We can also combine the same 2 atoms chemically. What happens when you put 2 hydrogens together chemically? Not much. You get a tiny amount of power, and you have a molecule of hydrogen gas. If you take the same 2 hydrogen atoms and you combine them nuclearly, you get 10 million times more power out of the exact same material. So the power is not in the nucleus, right? The power is in the mind. It's only that technique that allows that power to come out. So let's take a look at the next thing. The problem here is that in that first reaction, the common one, a neutron is created. Neutrons aren't very good. Because they do not have an electrical charge, we can't control them. So in your fusion experiment, as soon as the fusion occurs, the energy is released, the neutron is made, it goes and it runs directly into the wall of your experiment. It just hits the wall, and it makes the wall get hot. So believe it or not, these advanced designs, like the ITER being built in Cadarache, France, the way that this would create electricity in the future is that the neutrons will hit the wall, they will make the wall hot. The hot wall will boil water, and then the steam will blow through a tiny windmill. This is a very ancient way of creating power. So this is why helium-3 is so beautiful. I hope you can see the bottom row. This is the combination of deuterium and helium-3. If you add up the parts and you look at what they turn into, you see on the right we have a hydrogen and a normal helium-4. These are both charged particles. These can be controlled by the experiment. The motion of a charged particle, this is electricity. So the electricity can be directly created. This makes the plants 200% as efficient. And you could use these protons to use nuclear fuel. You could use these protons to create medical isotopes that right now would be very useful, but we cannot create them. You could use these protons and direct them out the back of a rocket. We have a completely different relationship to the universe with helium-3. So by creating these protons, these charged particles directly, we have a completely new form of fire. Fusion with helium-3 is a whole step beyond fission, because this fire does not involve heat. Right? This is a fundamental improvement. So let's take a look at what we do with this as part of a nuclear economy. This is the periodic table of Dmitry Mendeleev. And here we have a modern version. There are less than 90 elements that we can find in the crust of the Earth in any significant amount. But as you can see, there are more than 100 elements in this table. We created them. here you have a table not only of elements, but of isotopes. So going to the right, you have the number of the element, and moving upwards, you have the total mass of the element, the isotope. There's over 1,000 of these things. They have unique properties that we have not really investigated very thoroughly. A chemist doesn't care about an isotope. A plant does. A nuclear scientist does. So the nuclear economy has not yet happened. Now, where can we get this helium-3? Hopefully people are excited and would like to get some. There's only one trouble. On the entire Earth, there's only 1 ton of helium-3. It's not enough. But conveniently for us, there's 1 million tons saved up on the moon. So if we could get to the moon, if we can bring back this helium-3, it'll be useful. Even if the moon was made out of diamonds, it would be a waste of time to go to the moon and get the diamonds or the gold and bring them back here. Helium-3 is worth much more than its weight in gold. And China is moving in this direction. So just as the whole world rejoiced with the landing of Curiosity on Mars, with the landing of the Chang'e 3 on the moon, with India's successful orbiting of the Mars orbiter mission, we should all also be very happy that China has expressed an orientation to further lunar exploration and development, including helium-3. So I will allow the father of the Chinese lunar program, Ouyang Ziwan, speak about this. He said, "Helium-3, an isotope of the element helium, is an ideal fuel for nuclear fusion power, the next generation of nuclear power. It is estimated that the reserves of helium-3 across the Earth are only 15 tons, while 100 tons of helium-3 would be needed every year if nuclear fusion technology is applied to meet global demands. The moon, on the other hand, has reserves estimated at between 1 and 5 million tons. So what would a society, let's imagine, let's use our imaginations and let's move forward. Just like we might have done centuries ago if we start to think, how will the steam engine change life? How will electricity change life? Let's ask today, how will a helium-3 economy change life? How will it change mankind? Well, we wouldn't have any worries about energy. That's one thing. We could use incandescent light bulbs if we wanted to. You don't have to use fluorescence, right? We'd have plenty of electricity for that. We wouldn't have to worry about materials, because a fusion torch could dissociate into its base elements anything that you threw into it. 100% recycling. You don't have to put it in a different bag. Right? Even the oceans could be mined. There are trace minerals in the ocean water that we could take out and use if we need to. We could have new materials designed by their isotopes and have a whole new advance in material science. For example, artificially created diamonds that use only carbon-12 are stronger than normal diamonds. Or if you use only carbon-14, it's also stronger than normal diamonds. Right now we don't think about it, but this is the sort of thing that we will be doing in the future. If we have that kind of power capacity, we have plenty of water in the oceans. The droughts, the lack of water that we are facing today, this wouldn't be something that we worry about. When it's nighttime, we turn on a light. If there is a drought, we can turn on the water. This is the basis that we could have. And this will expand beyond the Earth. At the conference that we had here last April, one of the themes was planetary defense. We discussed the potential for a newly discovered asteroid or comet to hit the Earth, could wipe out a whole nation, could wipe out all of human life. We need to do better work for observations, including observatories in space to detect these asteroids. But most importantly, we have to be able to do something about them. Otherwise, imagine this. We might discover an asteroid coming towards the Earth and not be able to do anything about it. And you just know that, say, Germany will be gone in 2 years, and you can't do anything about it. Right? We shouldn't live that way. Now I'll show you 2 problems with chemical rockets. So this first video, we can start the video. I think you have to click on it to make the video play. There we go. Okay, so what we're seeing right here, this is the NASA Messenger mission. So you see the Messenger satellite, now it's got a green orbit. It's moving around. It was sent to study Mercury, and it was sent there in 2004. You can see the date. It's 2007. It's still not there. It's 2008. It's still not there. Plus, it's taking a very weird way of getting there. In 2011, Messenger finally got to Mercury's orbit. It took over 6.5 years to get there. It had to use 6 gravity assists, 1 from the Earth, 2 from Venus, 3 from Mercury, in addition to firing its rocket 5 times to change its orbit. In these gravity assists, the satellite comes so close to the Earth or another planet that it gives it a little pull. So this takes a long time. The next example, we can start this one. This is the, if we can start the video, this is the ESA mission, the Rosetta mission, which was sent to study a comet. So Rosetta was launched also
Rosetta
in
legt
2004.
insgesamt eine Strecke von ungefähr 7 Milliarden Kilometern zurück. Rosetta wurde im März 2004 gestartet, kommt 3-mal an der Erde vorbei, 1-mal am Mars und fliegt dann weit von der Sonne weg, ungefähr 5-mal so weit wie die Erde von der Sonne ist, in die Tiefen des Sonnensystems. Es könnte durchaus sein, dass von den Kometen da draußen auch die Bausteine, die letztlich zum Leben geführt haben, auf die frühe Erde gelangt sind.
Okay. So this was launched in 2004. It arrives and lands on the comet next month. 10 years it takes. And look at the path that it took. That would be like if you had a train schedule that you had you changing trains 10 times to go 20 kilometers. This is all that we can do. It's almost like having a hot air balloon, and we rely on air currents to push us in a very passive way. If we have fusion power, we could have a rocket that could go directly to any of these places as needed, reach any location in the inner solar system in only a couple of weeks, and we would actually be able to address planetary defense, among other threats. So I'd mentioned China's work on lunar development and on getting Helium-3. I got to say that in addition to getting the Helium-3, we also need to know how to make fusion happen. Because, I guess I didn't mention this, we can't do it yet. Right? The only fusion that we can really make happen is in bombs, and that's not very useful for us. So we keep doing more experiments. There's great work being done on this. China has a world-leading tokamak using superconductors. China plans to educate 2,000 fusion scientists by 2020. So instead of committing suicide like the European Union and the transatlantic banks are doing, that's the direction that the world needs to be taking. This means that we must look at the act of creating fire, the act of discovery itself. And so I'd like to conclude with some thoughts about the kind of thinking that we need to make the scientific breakthroughs in the future. So Mr. LaRouche has identified 2 triads of thinkers that he says are responsible for moving science forward. The first, which created modern science, was Filippo Brunelleschi, Nicholas of Cusa, and Johannes Kepler. Brunelleschi discovered that physics, not geometry, explained the shape of space in the small. And Cusa's discoveries on the very large, on intelligence as existing in between the contradictions of rationality, these discoveries were unified by Johannes Kepler. Johannes Kepler, in his beautiful life and his great work, he wanted to know God's reasons for making the world as it was made. Why were there the 6 planets that Kepler knew of and not 8? Why did they have these orbits and not other orbits? And what made each one move the way that it did? Why did they speed up and slow down? Kepler shocked all of the other people of his day by bringing earthly physics to solve problems up in the heavens. And he discovered that the sun was the cause of the motions, the composer of the planetary system as a system. And he did it by proving that mathematics could never discover what science could demonstrate. That's the first triad. very briefly on the second triad that Mr. LaRouche discusses. This triad is composed of Max Planck, whose discovery of the quantum nature of energy shook the concepts at the very basis of the very small. Also Albert Einstein, who partially implemented Riemann's program to develop the shape of space based on the principles that cause it. And third, Vladimir Vernadsky, whose genius mind gave us many tracks, many directions of discovery that have not been implemented yet. Most significant for Lyndon LaRouche's economics view is Vernadsky's concept of the noosphere, the action of thought on the surrounding environment. Mankind is a geological force, and thought is more powerful than, and powerful in a different way than volcanoes, gravity, magnetism, light. So, in contrast to these great thinkers, LaRouche points to the 1905 program by David Hilbert and Bertrand Russell to axiomatize mathematics and science generally, which would turn all of knowledge into a branch of logic, which would kill creativity of anybody who went along with this. Even though Kusa proved this was stupid centuries earlier, Kurt Gödel developed a devastating proof that even though Russell and Hilbert tried to remove metaphor, tried to remove creativity from the universe didn't agree. No complete system can ever be created. And that's the Riemann program for science, that the process of discovery is the foundation of science. The authority of science is not that it has the right answers. Since we will never have all the right answers, that cannot be the basis of science's authority. Instead, the authority of science is in how it overturns current thoughts to make a new, incommensurable discovery, one that does not fit into what existed before. So if we have a culture that's oriented around this identity, as the beautiful music we heard yesterday should inspire and help us to do, that's the victory that we have to seek. We have to eliminate oligarchy, hunger, poverty, and we have to eliminate uselessness. The highest duty of society and of nations is to provide an opportunity for their people to make lasting contributions to the future, to provide its people an opportunity to live lives that they can know were necessary and beneficial. Today, the greatest specific task for such a history-making scientific transformation is a fusion economy based on Helium-3. So the moon is out there. It's a reminder to us and a challenge to us to make the next leap. Thank you.